Right. So let's have a look at matrices. So when we're talking about doing a little bit of coding, and especially for practicing and for getting used to this kind of MATLAB handling of mathematics and data and biological thinking, we'd best not stick to the command window, which we have done so far, but the best thing is to open a new script. So there's a shortcut. It's either Control N on a Windows environment or Command N on a Macintosh and Linux environment. And if you want to have it by clicking, so on that bar at the top, you just click New Script. And New Script is just what I did. So it opens a new window. And what I want to do is I want to call it some name. So I call that my code. And I have that stored by default in the folder where I'm currently working. So having that stored helps me to now put multiple lines of code in one environment. And that's what we're going to do, such that we can go back and forth and make changes as we would like to have it. So maybe you have seen it with a little bit of delay. The file shows up on my desktop. This is just my current directory. And this is then the file that I could then also save and share with other people or use later on if I'm interested in any of the code that's in there. Right, so let's create a new variable. And what we want to have to do, we want to create a network. So if you have looked at the materials, you know that in order to create a network, we first need to define a network matrix. So how would we build up a network matrix? Well, we do it and we give it a variable. So say my network is something, and an easy way is to start a network by creating a matrix that is just filled with zeros. It's not zero, but it's zeros with an S. So the Americanized plural of zero. And then we have to specify how big that network is supposed to be, especially how many nodes does it have. So how many components are in that network. And in principle, you could put in a number here. So like if we wanted 3, you could in the number 3 here, and that would be fine. However, for good practice, we do something else. What we do is we create a variable, which is the number of nodes. Because this is something that we might want to have available for handling later on anywhere in the code. We just give it a variable name, and it's much easier than if you change the number of nodes at some point. To don't worry about what number you have just chosen. Just make sure that the number of nodes is uniquely defined. So if we say 3 followed by semicolon, this will just store the value 3 in a variable called number of nodes, NO subnodes. And if I using autofill here, that as an argument for zeros, it means the network will consist of as many zeros as there are nodes times or squared. Let's just see the result. So there's a couple of ways to have the code executed. In the editor, if you go to the editor tab at the top, there's the run button. So we can use the run button and it will work. Equally, it would work if I use a shortcut, that's Control Enter or Command Enter, and both will be possible. So I will use the shortcut for the future just to be a little bit less intrusive with that little arrow up there. But of course, if you feel more comfortable, do use that little arrow to run your code. So as an output in our command window, we can see the MATLAB returns that the variable name is my network, and it gives us the output, and it's 3 by 3 zeros, just highlighted in blue here, and that means we have created a network of 3 nodes, which can have a maximum of up to 3 by 3 equal to 9 9 edges. Right, so however, a network with edges that are all 0 is not very useful thing. So we now need to fill in the information about who is connected to who, which node has a connection to which other node. So let's do that. Let's put a semicolon down here to suppress output and then specify. So a change to my network. So I have to say my network is equal to something. Now I want to access a specific position in that network. So the best way to do it is to do that in round parentheses. So my network and the position can be identified as showing from where to where the edge is supposed to go. So if the edge is supposed to start in node number 1, we say node number 1, comma. And if it's supposed to reach number 2, then we say number 2. So from 1 to 2. In networks terminology, that's from row 1 to column 2. So we expect the highlighted node at the bottom to be replaced by whatever we specify. And if we specify that to be 1, then we want that output at the bottom to be 1, which it is now. So let me just copy and paste this code here. Copy, paste, and we can specify another node. Say there's a reverse connection from the second node to the first node. So that network has connection from node 1 to 2, but also from 2 to 1. So second row to first column should also be 1. Let's execute the code, and now we can see now there's a 1 here and a 1 there. So it's now symmetric compared to the diagonal of the matrix. So to the line that goes somewhere from top left to bottom right. And it means we have an undirected edge between nodes 1 and 2. And there's a bit of a slightly more complicated thing. We can also assign multiple edges at the same time. So let's do something that starts, take this away for the moment. Let's try to give connections from node 3. So starting from node 3, we would have to insert 3 comma, right? So it's from node. And now we want it to go a connection to node number 1 and a connection to node number 2 at the same time. So the way we can do that is to specify square brackets, and within square brackets, then identify nodes number 1 and 2 as targets. And if we execute that node, we can see that now we have from node number 3, we have added a connection to node number 1, highlighted now. And we have specified a connection to node number 2, highlighted now. So that's about how you create a matrix and how you fill matrix with meaningful entries. In this case, distinguishing ones from zeros. 0 meaning there's no edge at the specified position. 1 meaning there is an edge at the specified position. We could end this by saying now that we have set up a network matrix, its name is my network, how can we find out, and that means find out in terms of code, what is the number of nodes and what is the number of edges in that network? So quite simply, the number of nodes is very trivial because we have defined it. So number of nodes, if I just type it in the command window, we return 3. Because we have defined it as such, so that's very simple. Another thing is to find out how many edges there are. So what we can do is I just show you one example. So there's many ways to find out how many edges there are in the network, but one is to actually use the find function. Maybe you haven't used it so far, and means MATLAB trying to find a certain feature. And if it tries to find something in my network, then we have to specify that we're looking for something in my network. So the argument is my network. What are we looking for? We remember it looked like a matrix of 3 by 3 entries, and some of them were 0 and some of them were 1. But because edges were specified by being a 1, we can say, look for instances of that matrix being equal to 1. So note that equal is now a double equal, highlighted here. And a double equal, the equal is the logical equal. So it's actually a testing, like the question, is it equal to 1? And the reply will be where this matrix is equal to 1. Let's just see what the reply gives us. The answer to this question was 2, 3, 4, 6. Now, to understand this, we need a little bit of an excursion, and I'll show you very quickly how to understand this. You remember what the network looked like? So this is what the network looked like, right? So it was this matrix with the first column being 0, 1, 1. So instead of specifying a position by saying row and column, which we did so far, so we specified first row, second column, and so on, we can also use a single number to denote those elements. However, you need to know then what the counting convention is. And so the first column would be going from top to bottom, 1, 2, 3. Counting continues in the second column, so this would be element number 4, going down the column to 4, 5, 6, and the third column would be 7, 8, 9. So if I now go back to that code that we did before, that find my network equal 1, this is how the answer needs to be interpreted. There are edges in position 2, 3, 4, 6, where that matrix is equal to 1 in this counting that I just showed you. So what we could do, we could use that, we could say that's useful information, and we could say we store that in a variable called edges. So edges, maybe I call it edges with a plural because it's more than one. Edges are at position 2, 3, 4, 6. So how can we find out the number of edges? Number of edges is what in this case? The number of edges is, of course, the length of that variable called edges. Right? So there's a function called length. So you want to know how many elements there are in this case, array of one dimension. And using length, you can specify, well, how many are there? And the answer to this is 4, meaning this network specified by my network, the variable my network, contains 4 edges. And it means it's also easy to actually find that out about any network matrix that you have, how many instances of ones are there. And if 1 represents an edge, that's how you can do it. There's a bit of a warning here. MATLAB allows you to specify edges also by numbers other than 1. So you could, for example, say if an edge is very important, I give it a large number. And if it's small, I give it a small number. So then the way to count would not be to say that matrix is equal to 1, but if all numbers for edges are positive, so giving only the strength of the edge rather than just 1, then you would specify find where my network is larger than 0, or where it is not 0, right? If it's larger than 0, everything like this will be counted as an edge. That's just to say that we are giving basic code here, and this can be always advanced for more detailed coding later on.